First of all, I hope you're all doing well. We are looking at some pre-calculus stuff, and we're just starting to get into the trig stuff of pre-calculus. So this is going to take us some time to get through, and there'll be some work that you do and some videos you watch and things like that, and some activities that you have built here. One of the things we have to review today is from geometry, and a lot of times this gets taken out of the geometry curriculum just for time. But today what we're going to do is we're going to look at some special right triangles and why they're special. So why did we consider them special right triangles? The first one is the 45-45-90 right triangle. The other one was the 30-60-90 right triangle. And the reason why they are special, or why we've decided that we're going to call them special, is because they're both halves of regular shapes. So I'm going to just draw a square here, a 4x4 square, and we're going to call this a 1x1 square. So what I want you to think about is that this distance right here, from here to here, that segment, I want you to think about that as one, as a length of one. I know it's got just 4, so a quarter, a quarter, a quarter, and a quarter. So we go through this and we slide up there. Okay, so now if we take this and we draw the diagonal of this, we get a right triangle on this half and a right triangle on that half. And this right triangle here has a 90-degree angle. And because it's isosceles, because these two sides are the same here and here, we know that these two angles, this angle and that angle, are the same. So if you take 180 minus the 90 that we already know we have, is that's 90 divided by 2, it's 45. So now I have a 45-45 right triangle. And so I'm just going to hide the other half of this so we don't have to worry about it. If I click on this, oops, I missed it. Ooh, boy. There we go. All right. Now I'm going to hide it and hide and hide. So here's our right triangle. Hide. All right. And you know what? I'm going to go the other way with this. I'm just going to slide this over here. Now we have a right triangle going this way. Okay. So still 45-45-90 right triangle. Now I already said that this right here is 1, and I don't know if I can do a text box in here or not. It does not look like I can. So maybe if I click this, can I label it? Yes. I'm going to call that a length, but I don't want that length. I want that to be 1. Okay, good. That came up. And then I know that this one over here is label, and we're going to call that 1. All right. So now I want to know how long this side is. Okay. So this side over here is going to be the hypotenuse of a right triangle. So we can use our Pythagorean theorem. So if we take 1 squared plus 1 squared, and that's going to give me 2, right? 1, and then that's going to be here. That means that's the square root of 2. So I'm going to click this, and I'm going to call it square root of 2. All right, so there's the square root of 2. So if I would make this triangle twice as big, so let's see, if I'm going to make that twice as big, that means that's going to, instead of going over, this is going to have to go down 4 more here, and it's going to have to go out 4 more there. So right there. And now this triangle is twice as big as the other triangle. And because these are similar triangles from your geometry days, we know that if the two sides are twice as big, this is similar because it's 90, 45, and 45. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yep, 1, 2, 3, 4, 5, 6, 7, 8. Yep. Okay, so we know that this is now 2 over here, and we know this is 2 over here. So the scale factor is 2. So I can just ramp this up, and I can say now this side is 2 times the square root of 2. So it turns out that when you're dealing with a 45-45 right triangle, the legs are always the same, 1 and 1, and then this is the square root of 2. Well, what we're going to work on right now is I want to go down in the other way. I want this distance from here to here to be 1. I want this length to be 1. Why don't you pause the video for a second, and if I want the hypotenuse to be 1, what do the 2 legs have to be? That's what I want to know. So pause the video and for a couple minutes and do that. Okay, welcome back. I'm hoping that you found out that if this is 1 over here, then these have to be square root of 2 for this, because it's going to have to be square root of 2 squared plus square root of 2 squared, square root of 2 over 2. So square root of 2 over 2 squared plus square root of 2 over 2 squared, and that's going to give you, over here, that's going to give you 1. Whoops. I want to delete that. And I guess I can kind of show that to you by bringing up a, let's see, by bringing up just a text box. So again, you can, if you got this, if you got square root of 2 over 2 by square root of 2 over 2, and you're already set, then go ahead and you can skip ahead in this video a little bit. I am struggling with where I need to go. I'll just do it here. No, I'll go into regular decimals. That's and I just want the graphing calculator. Sorry, it's just taking so long. Accept. So we have, we want 1 to be equal to the leg squared plus the leg squared. And it's 1 squared to be like equal to the leg squared plus the leg squared. So that means that we want 1 to equal 2 times the leg squared, because the 2 legs are the same, right? So then that means that we want 1/2 equal to the leg squared. So then we want the square root of 1/2 to be equal to the leg. Now, plus or minus, yes, true, but we're talking about lengths here. And so that's the square root of 1 divided by the square root of 2 is equal to the leg. So that's just a 1 on top divided by the square root of 2 is equal to the leg. And then 1 divided by the square root of 2 times, I don't want that, just cleaning it up, the square root of 2 divided by the square root of 2. Why am I doing that? Because I don't want that radical in the denominator. equals leg, egg. And then, so that's the square root of 2. Divided by 2 is equal to the leg. That's what we got. So that's why each leg is square root of 2 over 2 when it is a right triangle, or when it's a 45, 45, 90 right triangle. All right, so now let's go back and let's go to a new, I'm going to get a new deal here. And delete all that. Okay, so now I want to talk about the other, that was the 4-sided regular figure. Now let's talk about the 3-sided regular figure. And that's a, to do that, that's going to be an equilateral triangle. So right now I have, again, this is going to be my 1. 4 boxes is equal to 1. And I want to come up with a point that's 4 boxes, that's the same length as 4 boxes away from both of these points. So I get these two things. So I do that with a circle. And I'm going to, there. Now I got all the points that are 4 boxes away from this one. And I'm going to do a circle coming back this way. There. Now I got all the boxes that are this at four boxes, or all the points that are 4 boxes away from that point. So this point right here, this special point, that's the spot where it's 4 boxes away from this point, and the same length is 4 boxes away from this point. So I have a 1 by 1 by 1 equilateral triangle. I'm going to put my segments in. And how do we get a right triangle out of this? Well, in this one, if it's an isosceles triangle and I drop in the altitude, so I'm going to drop in the altitude, which means it's got to make a 90-degree angle. So I'm going to come straight down with a 90-degree angle. Wait a minute. First of all, what are the angles of these? Let's see. Equal sides means equal angles, and there's 180 degrees in a triangle, so 180 divided by 3 is 60. So these are each 60 degrees. All right. Now, let's just double check. Choose a point, 1 leg, choose the vertex, there. 60 degrees, good. Okay, so there's 60 degrees. Now I'm going to drop this 90-degree in, and I think I can do that here. More tools. And I'm going to select the line, and I'm going to set the point right there. Okay, now I can hide this side because now I've got my right triangle that I'm looking at. I'm going to temporarily hide this, and then I got to put the point back on. Let's undo what I just did. I wonder if I can do that. Guess not. I wonder if Control Z does work in this. They're so smart. There we go. Now I got that point down there. Now I can go back and hide. And now I can make my segment. And make another segment. And there's my right triangle. So this right triangle, if you remember, it came from an equilateral right triangle. So what did this do right here? This was, this cut this opposite side exactly in half. That happens in an isosceles triangle. So this piece right here, I can label this, that's just equal to 1/2. Okay, and we knew this piece right here, because that's one of the full sides of that right triangle, that was equal to 1. But now we're going to have to go back and we're going to have to use the Pythagorean theorem to figure out what this side is. So if you want, you can pause the video and go ahead and do that. All right, welcome back. I'm going to run through it real quick in case you were not able to get there. If you were able to get the answer here, you should have got square root of 3 over 2. If you were not able to get there, then you can watch kind of how I do this. Let me get a new graph. Newton graph. Okay, so we knew the hypotenuse was 1 again, and that was equal to, and we knew one leg was 1/2. Oh, I'm going to get my... I'll get better and better at this thing here. And then there's the leg. There's the other. In fact, I'm even going to call it the long leg. Because there's two legs. There's that shorter leg and there's that longer leg. So there's that long leg squared. Okay. Then 1 is equal to, let's see, this is equal to 1/4 plus long leg. Let's copy and paste. And so we don't have to watch me type. There we go. Then if I move on to the next one, and again, feel free to speed up the video in this part because you probably don't need to hear me talk through each one of these steps. You just need to see it happen. So now I'm going to have, let's see, I'm going to say 1 minus 3/4 on this side is equal to the long leg squared. I guess I can just do that. So now this is equal to 1/4 is equal to long leg squared. Oh, shoot. 3/4. There you go. 3/4. And I'm subtracting 1/4. I got ahead of myself here. Sorry. There you go. You've probably seen what happened. All right. Now I'm going to, so now I got to take the square root of both sides. So SQRT of 3/4, Control C, Control V is equal to long leg squared. No, just long leg. So I'm not long leg squared anymore. It's just the long leg. Right? Oh, I don't want all those things. Get rid of that. All right. So now this is the square root of 3 divided by square root of 4 equals long leg. And then this is going to be square root of 3 divided by square root of 4 is just 2. So there's the long leg. So if we come back over here, I don't know how my label is going to turn out on this. They don't quite have it where I need it yet, but we'll do it. Add label, and we're not going to call it 3.46. We're going to call it square root of 3 over 2. Square root of 3 over 2. So now we have that piece. Good. Nice work. So that's your quick review there. We'll come back with another video here and put that on the we'll put that on the coordinate plane. Let's see. All right. That was longer than I wanted. Let me find this here. So we'll see you again in a little while.